Okay, so we've spent a good chunk of time looking at properties of logarithms, how we can combine them, how we add them, how we could evaluate them, but we haven't actually really put them into any good use. So that's what we finally get to do. So this last section, we're going to look at equations that have exponentials in them. We're going to look at equations that have logarithms in them, and how can we use logarithms and exponentials to solve these equations. You're going to need a calculator to get through most of these. And most of these problems will not come out to perfect, nice numbers. So just be ready for that. You'll need your calculator handy. So let's look at the equation 4 to the x equals 11. It looks like a really simple equation, right? Not a lot to do to solve this, except that 4 to some power, there's no nice power that comes out to 11. We can know that it has to be between 1 and 2, right? Because 4 to the first is 4, 4 squared is 16, but neither of those get us there, right? So it's somewhere between 1 and 2. So this is where we will use logarithms. A logarithm will undo an exponential. Now you have a couple options on how you want to solve this, and I'll try to walk through both, but again, it's kind of going to depend on what your calculator is able to do, because we're going to have to evaluate a log at some point, and depending on whether you can choose the base might make a difference what way you want to solve this. So here we have 4 to the x equals 11. To undo an exponential, we would take a log on both sides. Now, my calculator doesn't let me choose the base. I have to use either log or natural log. So from the start, I'm just going to use natural log. The main reason I pick that over log is because it is less to write. ln is 2 letters, log is 3, and g, in my opinion, is a pretty large letter to have to write. So I choose natural log, and it makes no difference to you whether you use natural log or log. Okay? But I'm going to take the natural log of both sides. We can do that just the same as we can multiply both sides of an equation by something. Just like we can add something to both sides, we can take the natural log on both sides. And so maybe now you see why this is going to be helpful based off of what we've done with the properties of logs. Since we have a log with something in an exponent, what can we do with that x? We get to take that x and put that out in front. So we would then have x times natural log of 4 equals natural log of 11. And now we just have x times natural log of 4. That's just a number. So this isn't really any different than having x times 2 equals 10. Divide both sides by 2, right? So here we have x times natural log of 4. So divide both sides by natural log of 4. Divide by natural log of 4. So x is going to equal whatever natural log of 11 divided by natural log of 4 is. That's something that we have to use a calculator for, right? So plug natural log of 11 divided by natural log of 4 into your calculator, and we get 1.73. All right, so we had said it has to be between 1 and 2. Looks like it is, so that's our solution. Now here's one difference. Let's say that you do have a calculator that lets you choose the base. If you have the calculator that lets you choose the base, what I would recommend is taking the log with the base of whatever you have here in your exponential. So we have a 4 to the x, so I'm going to do log base 4 on both sides. Okay? We can take that x and pull it out in front. And then what is log base 4 of 4? Well, 4 to what power is 4? 1. So this whole thing is just 1, and that completely cancels out and goes away. So then we just have x equals log base 4 of 11. Now if you have the calculator that can evaluate that, you're good to just punch that in right there. If you're like me and it just has the log or natural log, well then we have to use the change of base formula, and I'm going to end up doing that natural log of 11 over natural log of 4 from the change of base formula to evaluate that. And that's the same thing that I had to do up here anyway. Okay? So whether you start out by taking natural log on both sides, log on both sides, or log base 4, it doesn't really matter. You're going to end up at the same point regardless. So let's look at one that has just a little bit more going on. So here we have 7 to the 9x equals 15. Okay. Take the natural log of both sides. Again, you could use log or log base 7, and that would take care of things on that left side right away. Right? So natural log on both sides. That lets me move that 9x out in front here. So we have 9x natural log of 7. So now it's the same thing. I've got that x, but it's multiplied by 9 and natural log of 7. So I'm just going to have to divide both sides by 9 natural log of 7 to cancel those out. Cancel out the 9s. That leaves me with x over here. So divide by 9 and natural log of 7. And just make sure you do that carefully in your calculator. You could punch that in as natural log of 15 divided by 9 divided by natural log of 7. And that should do that for you. And punching that in, I get 0.15. All right, so x is 0.15. Let's throw more things into the equation, make it a little bit more complicated. In these cases, we need to get everything away from our exponential before we can deal with that exponential. That's not really different than when we had equations with an x squared, or when we had square root problems. We wanted to get everything away from that first. So first thing to do is going to be subtract 1. So 5 times 2 to the negative 2x equals 20. Divide by 5. And we get 2 to the negative 2x equals 4. And this one will actually work out a little bit nicer, because maybe you notice that 2 to a whole number power will give us 4. So you could go on by taking the log on both sides, and you would take the log, pull that negative 2x out in front, and then divide by a couple things. Or 4 is the same as 2 squared, right? So if we have 2 to some power on this side and 2 to some power on this side, and we want these two sides to be equal, well, then our exponents have to be equal. So essentially you could take log base 2 on both sides, and we would end up with negative 2x equals 2. Divide by a negative 2, and x is, excuse me, negative 1. Maybe it'd be good just to walk through the other steps. So if we go back to having 2 to the negative 2x equals 4, if I take natural log on both sides, then I would end up with negative 2x times natural log of 2 equals natural log of 4. If I divide both sides by natural log of 2, if I do just that part, then natural log of 4 divided by natural log of 2 comes out to 2. That comes out evenly. And divide by that negative 1, and you still get x is negative 1. One last example. I would think you're catching on by this point, but we'll do one more just because. This one we have e in there, so our base of our exponent is e, so that would probably tell us that we should use natural log. If you have e as the base of your exponential, you're going to use natural log. Okay. So first steps here, get everything away from that exponential. So add 7, so that's 4e to the negative 0.3 x equals 20. Divide both sides by 4. E to the negative 0.3 x equals 5. So at this point, we would take natural log on both sides. This negative 0.3x would pull out to the front. And then here we don't have to worry about dividing by natural log of e, because what is natural log of e? Well, that's asking, again, e to what power is e? that's just 1. So that would be times 1. So we have negative 0.3x equals natural log of 5. So divide by negative 0.3. And x is, when we plug that into our calculator, a negative 5.36. So that's it for solving exponential equations. Take a log on both, move everything away from that exponential. Okay, get everything away from that exponential first. Take a log on both sides. It's up to you whether you want to use common log, natural log, or choose the base of that exponent. And then pull out the exponent from inside of your log, divide by a couple things, and there you have it.